a quick review on how to graph sine, cosine, tangent, cotangent, secant, cosecant. And then what the coefficients in front of the function, as well as the coefficient in front of the x, does, because on the web work, you'll have problems like 4 cosine 2/3 of x. And I don't think the videos in this section cover what to do with the 4 and what to do with the 2/3. So once I do a review of those 6 graphs and how you graph them, we'll talk a little bit about what those numbers mean. Okay. So the best way, I think, to think about sine, cosine, tangent, if I can get my board to pay attention to me here. This is terrible. I don't know why it's being so slow. Let's try it here. Okay, not the best unit circle, but you get the idea. All right, so remember, if it's a unit circle, what are these points? What are the coordinates? Remember?
0, 360 is 0, 1.
How about 1, 0? X is 1, Y is 0.
And that one is 0, 1.
Yep.
That one's
Negative 1, 0.
that one's
0, negative 1. Okay. What do we also know those coordinates represent?
is the one, or what x is or cosine, y is tan.
Right, sine. Okay, so given that I've got this unit circle, if I were to actually draw xy coordinate, and I'm going to try and match it up somewhat with the center of this circle, and you're always, when you start with the sine, cosine, all of those graphs, you're going to do it and just focus on 0, pi over 2, pi, 3 pi over 2, 2 pi on the positive side, and then the same thing on the negative. So if I do pi over 2, pi, 3 pi over 2, and then 2 pi is here.
That one's 0.
Yep, this is 0. And then I have negative pi over 2, pi, negative, 3 pi over 2, and negative 2 pi, right?
Yeah.
Okay, the highest this graph is ever going to get is, if I can get these, what, 1, 2, 3, 4, 5, 1, 2, 3, yeah. Trying to just line them up with the circle so you can kind of see. This is 1, and this is negative 1, right? Okay. So sine at 0 degrees, or 0 radians, is what value?
Oh, 1, 0.
0. So for my sine graph, it's right there. At 90, what's sine?
1,
At pi, what's sine?
0.
0. 3 pi over 2, negative 1, and back to 0. Right? And then the same, if I go from this point and go negative pi over 2, I'm at negative 1. Right?
And then 0, and then positive 1, and then 0, and then...
Yep, and then 0, then positive 1, and then back to 0. Okay? Okay, there's your sine graph. Okay, cosine, if I do it in red,
It's the opposite.
yep, cosine of 0 is actually 1. And cosine of pi over 2 is 0. And then we are at negative 1, 0, and 1. And then here we are at 0, negative 1, 0, and 1. Something like that. Going on forever.
Yeah.
Okay? So basically, sine and cosine are the exact same curve.
Just different.
One is shifted pi over 2 from the other. If I took this point and I shifted it pi over 2, I'd end up here. And it's actually shifted what? Negative pi over 2.
Okay.
If the blue shifts this way,
Or the red could shift.
or the red shifts, yeah. But the blue, if the blue shifts this way, pi over 2, it's almost the exact inverse. But if it shifts this way, pi over 2, it's the same graph, right? Okay, so talking about period of these graphs, the period of a graph or a function means if it's a function like this, how long or how many radians does it go through before it repeats itself? So look at the sign, the blue function. If I were to pick the point to start right here, how long before it's back to this point with the line starting to go up again?
4 pi.
Well, 2 pi really, because at this point it's heading up again.
Okay, so like lots.
So from here to here is one full cycle of sine.
Okay, so is that 2 pi? Wait, what's
This is 2 pi.
pi over 2 is the first one, right?
Yeah, pi over 2, pi,
From 0 to 2 pi, so it's just 2 pi.
2 pi, right? 2 pi is the period. And you'll find with cosine it's the same exact thing. It takes 2 pi rotations, so it has to go through the full circle, and it's back to starting over again. Okay? So the period is 2 pi for sine and cosine. Okay? Now, looking at tangent, what is tangent in terms of sine and cosine?
Sine over cosine.
Okay, sine over cosine. So if I were to figure out what tangent is at this point, I would take sine over cosine, which is
0 over 1.
which is
0.
0. Okay, so at 0, tangent 0. At pi over 2, what's tangent?
Undefined.
Yeah.
0 over 0.
At pi over 2, tangent is undefined. Stop. Okay, what about at pi?
0.
Okay, so at pi, tangent is 0. What about 3 pi over 2? Yep. Okay, so I have these points to start with, so let's just do another graph here. And I'm going to break it up into pi over 2, pi, 3 pi over 2, 2 pi. And the same thing here. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And let's call this 1 and this negative 1. Okay, so at 0, actually I want to put points there. At 0, what did we say tangent was?
0.
0. At pi over 2, what did we say tangent was? Undefined. So I have an asymptote.
We're undefined?
Yep, that's, remember from rational functions, anywhere that a function is undefined, the function, the graph can't touch that place. It's an asymptote. Okay? We also knew there was an asymptote at 3 pi over 2. Come on. Okay? And we'll also see that there's one at negative pi over 2, negative 3 pi over 2. So the only point right now I have is 0. That's not going to help me much. Where is tangent 1? If it's sine over cosine, what do the values of sine and cosine have to be for tangent to be 1?
1, both don't be 1.
They both have to, one divided by the other has to be 1, so they both have to be the same value. What angle are sine and cosine exactly the same? 45 degrees, right? Square root of 2 over 2 for both. Okay, so at 45 degrees, tangent is 1. So this is pi over 4, right? Right, and you're going to find is it 1 or negative 1 here?
Negative 1.
Negative 1 because cosine's negative. Is it positive or negative here?
Negative. Oh,
Positive.
Both.
Yep. Positive 1, negative 1, positive 1, and negative 1. Okay? So if I look at these points, pi over 4 is halfway between 0 and pi over 2. It's 1 here.
Okay.
And at the halfway between this one, it's negative 1. Right? Whoops. Negative 1. And we're back to, there should be yeah, we're back to 1 here. Right? And we're at 1 This is negative pi over 4, so that makes it negative 1, and positive 1, and negative 1, positive 1, so on. Okay, so the tangent graph can't go beyond this asymptote, and it can't go beyond that asymptote. Is that what I want? No. I want to go through 0 and down. So that's tangent. And so on. That's what tangent looks like. It's going to be this same graph over and over and over again between every asymptote. Okay, so what's the period of tangent? How long does it take to repeat itself? How many radians?
5/2.
Well, this is the full graph from here to here.
So 2 pi.
So it goes from negative pi over 2 to positive pi over 2. Negative pi over 2 to positive pi over 2. Negative pi over 2, positive pi over 2. So how many?
1
Pi, right? So the period of tangent is pi. And cotangent is the inverse of tangent, right? So you're going to do the exact same thing, except the asymptotes now are going to be everywhere cotangent was 0. So now the asymptotes for cotangent are here, 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 and so on. So your asymptotes are a little different. And maybe I'll put them in black here. So cotangent's here, here, and then, that's all right, your graph for cotangent is going to look like this. Okay? So it's also the period of cotangent is pi. Okay? So the period for tangent is pi, and the period for cotangent is pi. Okay? So just to sum up, if I were given this function, I wanted you to graph it. The graph of this function is going to look very similar to this graph here of sine. The only difference is instead of going up to 1 here, it's going up to 4. Instead of going down to 1 here, it's going down to negative 4. The other thing is this coefficient. So this has to do with amplitude, just how much it stretches up and down. This tells you how the period is affected. Okay, so to figure this out, you're going to take 3 and you're going to divide it by the period of sine, which is 2 pi. Okay, and so this tells you the new period. It's 3 over 2 pi instead of just 2 pi. Okay, so it basically repeats itself. No, the period now is shrinking. It's going to have to go 3 over 2 pi.
Okay, so it was
2 pi, and now it's 3 over 2 pi. Yeah, so it's basically, it shrinks if it's greater than 1, that coefficient. It stretches it if it's less than 1.
okay.
Okay, now the only difference is if you're looking at tangent, cotangent here, well, then you would divide by pi instead of 2 pi, because the period of tangent and cotangent is pi. Secant and cosecant have the same period as cosine and sine.
And the graph?
And the graph has asymptotes because cosine and sine at some point are 0. Everywhere cosine 0, secant has an asymptote. Everywhere sine is 0, cosecant has an asymptote. Okay, and I think the graphs cover how to graph the regular
It does on the video.
secant, cosecant. So this is the piece that it really didn't talk about that you're going to need to know for web work. Okay? Yep. All right.